So, how do we find this rule? Well, it's not always one way of finding the rule that we would use, but there are some things that we learned in grade 10 that are very good starting places. I'm just going to set up a table of values and do a few familiar things. So we're moving beyond recursion for just a minute here, because recursion doesn't help us to get here. Or it helps us to get here in the sense that it might give us the numbers for our table, but it won't directly give us the general term. Okay, so let's call the first term term 0. And there's a good reason for calling it 0 as opposed to 1, which will become a little bit more obvious in a minute. You could call it 1, but then when you try to make a function, you'll find you have to shift everything along to be able to do the things you know how to do with functions. So term 0, the first term, has 1 square, next one has 5 squares, this one has 13 squares, 25 squares, and 41 squares for the next one. So I see a table of values. I don't know what function it represents. There are a few things I can try. The most obvious being I'm going to check the first differences. Well, I got 4, I got 8, I got 12, I got 16, but I knew that already, right? I knew that from making my recursion formula. I'm going to check my second differences. That's clearly not linear. My second differences will tell me if it's quadratic or not. If I don't get anything for my first, second, third, or fourth differences, I could keep going. It could be maybe that it's not linear, quadratic, cubic, or quartic. It could have some much higher degree. Or I could check for common ratio to see if it's exponential. We haven't talked about that yet. We'll talk about that later. But it turns out anyway, for now, that the second differences are all the same. So it is in fact quadratic. That's a good first step. I've identified the type of function. Okay. I don't know if you know this, but if you take your second differences and divide them by 2, you get the a value for standard form. So standard form is here. Some things to remember from before are that C is the y-intercept. And the second difference is delta for difference divided by 2 give you a. Alright, well that helps. I think we have enough information to actually find the entire function. Let's do what we can. I'm going to choose 1 point and substitute that. I think I'll pick 1, 5. So choose 1 point and substitute. Doesn't matter which one you pick, they should all work. So here we go. We have y equals, okay, our a value. Second difference is 4. 4 divided by 2 is 2. So I'm going to put a 2 there. I don't know my b value. I know c is the y-intercept. Y-intercept is, well, when x equals 0, right? So there's the y-intercept right there. So So I'll put a 1 in there. Now I'll substitute this point, 1 comma 5. So 5 goes where the y is. Nope. Well, that wasn't the color I meant to use, but no big deal. And we have a 1 for the x value. We still don't know what b is, but that's okay. We're almost there. Okay, so 5 equals 1 squared times 2 is 2, plus 1b, or b, plus 1. Okay, and b is obviously equal to 5 minus 3. Okay, and b is equal to 2. So the function that models this relationship, which we can use to find the 100th term, which I won't do right now because you would know how to use this, no problem, is the following function. Just bracket this off. There, I think we need a C. We said b was 2, so now we have 2x squared plus 2x plus 1. There we go. And this will give us what recursion can't, in that we will substitute x equals 100 and find out what the output value is.